Welcome back to the sixth episode of Python Mastery. In the previous episode, we introduced several data types. Although there are many data types available, what we covered is sufficient for a start. In this episode, we'll explore the concepts of sequence, selection, and iteration. A sequence in programming refers to executing a series of statements in the order they appear, from top to bottom and left to right, without skipping or branching out. Each step is executed exactly once and in a linear fashion. For example, suppose we have a Python program that calculates the total cost of items in a shopping cart. Therefore, we will write a program named shopping cart. Now, when we run the program, the output will appear as follows. We didn't save the program, so we save it and then run the program. As you can see, the program has executed line by line. It's worth noting that \n is used to move to a new line. Here, look at the program. We use this \n for this new line. And .2f is used to format the output to two decimal places. Here, you can see two decimal places because of this .2f. For example, if we use .3f, we see three decimal places. Here, we can see three decimal places. Okay. To better understand how sequential execution works, we'll first set a breakpoint on line 1. Then we'll run the program using run and debug, stepping through it line by line so you can clearly see the sequence of execution at each step. You now see the first print result. Because we go forward step by step, we won't see the other print results until we run them. We will go forward here, step by step. Now you can see the second print result. You can see that each variable at each step added to the local variables here. If you look at this, you will see the tax rate because we run this line of code. But you won't see the tax because we don't run it until now. After we go forward one step, you will see the tax in the local variables here. Look at it. You can now see the tax variable here. Now the total amount has been added to the local variables. This example clearly demonstrated how a program executes sequentially. Now, it's time to become familiar with the concept of selection. Selection, also known as conditional branching, refers to a programming structure where the program executes different blocks of code depending on certain conditions. It typically involves decision-making using conditional statements like if, elif, and else, or match and case. For example, we want to write a program that takes a number and determines whether it is positive or negative. And then We will write a program that takes a student's score and determines whether it is the grade of A, B, C, or etc. Now we use the pseudocode for writing the first example. Step 1. The program starts by prompting the user to input a number using the input function. The input function takes user input as a string, so we convert it to a float using float to handle decimal numbers. This is an example of type conversion. Pay attention to this spacing. In Python syntax, this is called indentation. It is used to indicate that any code written with indentation under an if statement is considered a subblock or child of that condition. In other words, indentation defines the scope of control structures like if, for, while, etc. Without proper indentation, Python will raise an error. Here, The first if statement checks whether the entered number is greater than 0. If the condition is true, it means that the number is positive, and the programs print the number is positive. The elif stands for else. If a statement checks whether the number is less than 0. If the condition is true, the program prints the number is negative. And at last, we have else. If neither of the first two conditions is met, the else block is executed. This implies that the number must be 0, and the program prints the number is 0. Before writing the second example, I'd like to introduce three major types of operators in Python. 1. Arithmetic operators. 2. Relational operators. And 3. Logical operators. Arithmetic operators are used to perform basic mathematical operations on numeric values. You can see the common arithmetic operators here. Relational operators, also called comparison operators, compare two values and return a Boolean result. This means the output of relational operators are true or false. And logical operators are used to combine multiple conditions or Boolean expressions. They return true or false based on logical relationships. Here's a truth table that clearly shows the behavior of logical operators, or A or B, A and B, and not A, using binary values 0 and 1. Look at this. The AND returns true if both conditions are true. So if one of them is false, the result will be false. Or returns true if at least one is true, and not reverse the result of the signal. Now it's time to solve the second example. First, we will write the pseudocode and then we will complete the actual code. Here we use the AND operator, which is a logical operator, and for the condition to be true, both given conditions must be true. It means the score must be greater or equal than 19, and the score must be less or equal to 100. Another way to write comments is by using triple quotes or double quotes. This syntax is normally used for assigning multi-line strings to a variable. However, if it's not assigned to any variable, the interpreter automatically treats it like a comment and skips over it during execution. So here, these sentences will be a comment. Now we will run the program and observe the results for different outputs. We didn't save the program, so we save it. We see that for a score between 90 and 100, it returns an A. And in the description, we see that the program writes excellent. For a score between 80 and 90, it returns a B. For a score between 50 and 60, it returns an E, and in description it writes needs improvement. For values less than 50 and greater than 0, it returns an F. If we test invalid values, it will return invalid. Note that if we wanted to write a condition to check whether the number is negative or greater than 100, we would not use AND. Instead, the condition would be written using OR as shown here. Let's test the program. There are three main scenarios where it's better to use match case for selection in Python. 1. When you're comparing a single variable against multiple fixed values. 2. When you're matching a structured data. 3. When you want a scalable and maintainable code. Now, let's look at examples for each of the three scenarios. The first scenario is when you compare a single variable with multiple fixed values. In this case, it is better to use matching case, like this. Match command. For other cases, we use underscore. The second scenario is when you match the structured data like tuples. So let's change the point. The third case is writing scalable and maintainable code. For example, API responses or config handling. This is when you're handling enums, command types, or status codes. And for cleaner syntax, easier to maintain. For example, this line is used for the OR operator. To keep this part from getting boring, we'll cover loops in the next episode. Don't forget to like and subscribe.